We're going to check how much power the amplifier can do at 6 ohms load. This is our load here, 6 ohms resistor. This is our symmetrical power supply here, 40 volts. We have a 1 kilohertz. We have a 1 kilohertz input signal here. Currently our output is about 25 volts. Gonna increase the output until the sine wave clips. Alright, that's about 72.8 or 7. Suppose it. See, there's a little clip there. See, it's clipped now. The top of the sine wave is flat now. The output is about 72.8, about 73 volts peak to peak. Our input is 2.8 volts. The output of the power supply seems stable. Okay, so this is how we're going to get the RMS output of the amplifier. First, we need to convert the peak-to-peak voltage output to RMS. We just need to divide the peak-to-peak one day by 2.828. So that's about the maximum voltage output the amplifier can do without clipping. See the sound wave there, the top is nice and smooth. The output peak voltage peak to peak is 72 volts. So to get the RMS is we're going to divide 2.828. That's about 25 volts. Now we're going to square that and divide by 6 ohms. Six, so that's about 108 watts RMS. So the output of the amplifier, maximum output of the amplifier without clipping at 6 ohms load is about 108 watts RMS. Now we're going to see how much power the amp can do at 45 volts power supply. I'm just gonna adjust the output of the power supply to 45 volts. Right, that's good enough for 45 volts. Right, dump it up. Okay, it's clipping now, so we're just going to lower the voltage input a little bit so that it's not going to clip. Right, so there's no clipping there. There's also no clipping at the bottom. Right, the maximum output is about 80 volts. 80 volts peak to peak, and we're going to check how much is that. Oh, what's happening with right, 80 volts divide 2.828 squared. Oh, with, right, so that's about the maximum output the amplifier can do at 6 ohms load with 45 volt symmetrical power supply. It's 130 watts RMS at 6 ohms load.